Here we're reaching perhaps the most important portion of both lectures, Chapter 7, Substitution, and Chapter 8, Elimination. And here you will be able to tell which mechanism the reaction went through and, of course, draw the appropriate product. Be aware that in order for you to do this, you really have to have a thorough understanding of each mechanism, its transition state, energy diagram, rate, of course, solvent, alkyl halides, base or nucleophile, etc. So all of this is now going to be applied. So let's begin. This is a chart that is very, very helpful. We will go over examples, beginning with tertiary alkyl halides, going all the way down to primary alkyl halides. In the summary sheet, you will be able to tell which mechanism would be the most appropriate one. And again, of course, refer to this all the time. So let's begin with tertiary alkyl halide. You should be aware that there's no SN2 in tertiary alkyl halides. It's simply 2 sterically hindered. However, you can have SN1 and E1 with polar protic solvent / weak base. And of course, you may have E2, where we'll examine that down here. So let's say this is the example. You will have SN1 and E1 products. How do I tell this? Well, I'm going to start with the alkyl halide. I have a tertiary alkyl halide. I have a good leaving group. And when I look here, I have a protic solvent / weak either base or nucleophile //. So the only possible reactions here are SN1 and E1. And you have to draw both unless it's specified. So the SN1 product would be a substitution, meaning you take the methanol, kick the Cl out, and it replaces it. Remember, -1H. And for the elimination, you would have either this product or the double bond would be on the other side right here on the top. So this would be SN1 product. This would be E1. Once again, this is your alpha. So these would be your beta, beta, beta. Of course, we take from the most substituted, and in this case, the ones in the ring are more substituted than this, which is a methyl. So that's how you would draw it. Now, to give you an idea, SN1 usually predominates, meaning you'll have much more SN1 than E1. Some books report up to 95% SN1 product and E1, but it varies, so we're just going to include both. So anytime you have the possibility of SN1, E1, you will include both. However, if you would like to only or make more E1 product than SN1 product, you would have to use heat, high temperature. So this is above room temperature, which is 25 degrees. This is 65. So again, compared to 25. So this is 40 degrees warmer. So in this case, this is only the E1 product. You only draw the E1 product. Now, E2 takes place if you have a strong base. That's a charged base. And we know there's a charge here. This is Na plus and O minus. So that's a charged base. And of course, it's in its solution. Don't let this confuse you. Think that this is a protic solvent. Again, this is the ion in its solution. But if it was just methanol, then that would be an SN1 E1. So in this case, you have an E2 mechanism, which is again right there. It's the same product as the E1. Once again, there's no SN2 because it's tertiary alkyl halide. It's too sterically hindered, only E2. Now, when we go to the secondary alkyl halide, this is where it gets a little bit more, I would say, involved. So if you have protic solvent, a weak solvent like this is a protic solvent, then you are sure that this is going to be an SN1 E1. It's a weak solvent, weak base, weak nucleophile. So in this case, I mean, for now, this would be the product of the SN1, where we replace it from here. Although the product can look a little bit different, but I'll keep that until we get to chapter 10. But for now, just draw it the same way you were shown in class. And then the E1, you have your alpha here. This is your beta. This is your beta. Again, you're removed from the one that has less H's. So there's an H on this one. There are 2 H's on that one. So the base would remove from here. Therefore, this would be your product, the E1. Now, E2 requires a strong, if available, bulky base. And the SN2 requires a strong nucleophile. In this case, this is going to be an E2 because you have T-butoxide. That's a bulky base. Tert butoxide. So it's going to give me the same product as the E1. Again, this is E2. And for an SN2, it would be this one because this is a strong nucleophile, but a weak base. And the reason why it's a weak base, one way of doing this is you can check your pKa table to check the pKa of H2S. And it's going to give you a pKa that is corresponding to a weaker base. It's a low, it's going to be a low pKa. Low pKa means a weaker base. Not only this, you should know that this is a strong nucleophile but a weak base because, again, S is a large atom. It's a large atom. So it accommodates the charge readily, but because it's available, this lone pair, it's more polarizable, meaning, because it's a bigger atom, that lone pair can be shared readily. So the SN2 here would be the replacement of Cl with SH. Again, this is Na plus and S minus. So it would be right here. SN2. Okay, so polarizable atom, meaning shares lone pair readily. But it's a weak base. So it's a weak base. Now, the primary alkyl halide is generally not an issue. It's most of the time is SN2. There's no SN1 or E1. So at least it's easier for you to do these. But you may have an E2, although it's not that much favored if you have a bulky base. But primarily, this is going to be SN2. This is not a bulky base. It's just a 3-atom anion. So Na plus and N3, there's a minus charge. So what's happening is that the N3, the azide, is going to replace the bromine. Right there. You have an aprotic solvent which favors SN2E2. Now, of course, remember, DBN is a bulky base. So you cannot do an SN2. You can't just take DBN and stick it there. It's too big, it's too large to reach that carbon. So for that, you are doing an E2. So this is SN2, and here you're doing an E2. So that means here's your alpha carbon. Here's, you only have one beta carbon, so the double bond would have to form right there. So that would be like that. That's your product. So go over the homework. Go over also the SN2, SN1, compare them with the E1 and E2, and again, be able to get to this point where you discern which one is an SN1, E1, E2, SN2 mechanism. And we'll do more when we meet, but please bring questions with you.